Let's start with our first poll. Are you guys asleep? Yeah. No, but yeah, I mean, at least some of you attended, and that's thank you for that. So, again, I just wanted to thank you, the CSharpCorner, the annual conference, and to all the organizers. A big shout out to the organizers and also to the volunteers. You guys are doing really good work. Thank you. Thank you for organizing this. Thank you for inviting us over. And a huge shout out to the audience. Okay, some of you who are here, really thank you for attending. I know this is like a dead slot, right? Everybody's sleepy, including me. I woke up at 4 a.m. today to take the flight here. Perfect. So, very briefly, who I am, what I do. I am currently an assistant director cloud practice at EY. EY is Ernst & Young. Some of you might have heard of it. It's one of the big four firms. So when we say big four, it's like PwC, EY, then Deloitte and KPMG. Okay, so mostly they used to initially do audit, assurance, tax, but now they've also started doing consulting. So I'm part of that. Before this, I used to lead the Cloud Center of Excellence CCOE team in Accenture. So I have been doing this for around 10 to 11 years now. I started my journey with Samsung Research as an R&D engineer. Then I went to PwC, PricewaterhouseCoopers, UK. Then I came to Accenture, and now finally I am at EY. Out of the 10 years, I have been doing around 5 years cloud computing. Okay, so I have been with cloud started with AWS, now mostly in Azure. I hold around 40 plus Clouder IT certifications, and I'm also speaking at Technology Conference, and I'm a DevOps Institute ambassador. Okay, so a very quick poll. What do you guys do when I say the option? Just raise your hand. College first and second years. Okay, 1, 2, perfect, a lot of them, good, thank you. College third and fourth years. Okay, a lot of you. So yeah, most of you are from college, okay, including you. Working professionals, 1 to 5 years. Okay, 1. 5 to 10. Nobody, no issues. 10 to 20. 1, thank you for joining us. And 20 plus, oh, 10 to 20 you are also, perfect, thank you. 20 plus, oh nice, thank you so much for joining us. Okay, so see, don't think of this session as me telling you something, okay? Think of me as a friend or as a colleague, just bouncing off some ideas with you, okay? And because much of this session was more focused on enterprise clients, okay, like executive management and stuff, but I see most of you guys are from college and first to fourth years. So I will skip some of the slides and focus on some of the 101 slides more. But in the interest of some of the working professionals who attended, I will kind of try to keep it balanced. So again, this is a strategy session, okay? So I will try to kind of invoke the thought about some of these topics. And if you can kind of even think 5 to 6 minutes on some of these topics, that's good enough, okay? You don't need to take home anything other than some of the thoughts I'm talking to you about. So basically, let's discuss the art of the possible. Okay, so why I'm saying, let's just keep it at that. When we focus too much on tactical implementation, we sometimes forget about the strategic focus of vision, which is true, okay? So for example, I mean, even for example, when you're giving an exam maybe, when you're just thinking about, for example, scoring the next marks or something, you might sometimes even forget, for example, how does it end up, or how does it add up to the next phase of your life? Maybe it's a job or master's degree or something like that. So let us today focus on the strategic part of things. Some assumptions I have made, but again, I think most of these assumptions are wrong. That most of you guys are aware of cloud computing. Maybe some of you are at a high level, but I will try to go into that. And you have some basic idea about microservices, because that was the essence of this session. But again, I will have to kind of change my session accordingly. I will try to leave some questions, leave some time at the end for questions, but again, I am here for the next 2 to 3 days. You can kind of catch hold of me and ask me about anything. Okay, I've been doing this for around 10 years, so I've been in this industry for quite some time. Okay, let's get this party started, right? So scaling your CI/CD setup for cloud native microservices via InnerSource. It's a very complicated topic, right? I mean, so we will kind of try to remove the complications out of it. Again, this is agenda, but I will not stick to this agenda because the audience has changed, very frankly. So let's just kind of think about microservices. So how many of you, for example, can somebody tell me what is a microservice? Anybody? Anybody of you have any idea? Exactly, I think, yeah, I will obviously ask you, but anybody else in college anybody heard about the term microservice? Okay, no, but no. Have you heard, for example, okay, let me first start with you. Can you share something about microservices or something like that, yeah?
Yeah, we break the entire application into loosely coupled services.
Okay.
That way discoverable.
True.
They can scale independently.
True. Okay.
Lot of other factors.
Yes, true. Okay, so let me ask to some of the people. I mean, have any of you ever designed a web application? Okay, some of you have, right? So okay, you have, perfect. So say for example, you have designed a web application. So what did it have? It had maybe some HTML5 pages, maybe as a front end or something, maybe a little bit of JavaScript. And maybe what did you use for kind of like the backend coding, C#, Java, something of those sorts maybe. So see, the problem with enterprises is that they are doing what you are doing at a very, very huge scale, which is the truth, right? They are doing at a huge, huge scale. For example, we are doing some of the activities where we are getting 1.89 million hits on some of our systems every minute, which is like quite a big thing. So I mean, logically, if you think about it, if there is a very big system, okay, it's very hard to manage. That's the truth, right? Anything in our life, if it's too big, it's very hard to manage. So what is our logical way of thinking about it? Say, for example, you face a huge problem. You have to go to this friend's house, that friend's marriage, and stuff like that. How do you kind of logically isolate stuff, right? Okay, let me plan my, say, Diwali in this way. Let me spend the first 2 days with my girlfriend or boyfriend. Let me spend the next 3 days with my parents. You try to break down a big problem into small problems, right? Because that is how we feel that, okay, I can control that and I can kind of interconnect them. So this is microservices basically. When you think of a very big system, okay, and you kind of split it into small subsections, and each of those sections are independently controllable. This is very important. I need to be able to control it. Why? Because if I can control it, I will be able to basically manage its scale. I will be able to ensure that, for example, if it goes down, the other part of my application doesn't go down. Say, for example, if I tell you, say you have made a plan in Diwali with a single friend. 5 days you are going to with him or her to Uti. Okay. And then, for example, he or she falls sick. You don't have any backup, right? That is the idea. But if, for example, you had split that plan into, say, 2 and 3 days, at least if 2 days would have been lost, you would have still another 3 days. So if a big problem, you can make up into small problems. Similarly, enterprises, like say EY or any other enterprises, we try to break big problems into small problems. And this is microservices, and very frankly, this is kind of the talk of the town now. Maybe in a college level, you might not be that exposed to it, but when you join say, for example, some of you are in 3rd or 4th years. In 1 or 2 years, you will join a company, right? Maybe an IT company. Then this will be extremely important for you guys. So as I said, microservice architecture, it's like small services. You take a very big service, and I will show you something along those lines. Say, for example, if I take this. So this is, for example, in the left, you have a very big monolithic kind of an architecture. What is a monolithic architecture? It's like a very big building. Everything is in there. And what is a microservice kind of an architecture? You have split some parts out of it, and you have made them independently scalable, independently deployable. So if you see here, I had a UI layer, I had a business layer, and I had a data access layer. These are the 3 components I had of my application. It's a very standard web application. Most of the applications that you guys will work with in a few years, it will have a front end, right? That is the one you interact with. And then in the middle, you will have some sort of a compute. So say, for example, as an user, I will go to the front end, meaning I will say, for example, there is an application to upload images. Okay, so I will basically act as I will interact with the front end. I will give my data. I will upload my image, click on a button. But that's my work. I don't do anything else. Then what happens, basically, there is a middleware, something happening in the backend, which processes this. So if you take both of this into a same system, then your system is a monolith, so to speak. If you can break your front end separately and your back end separately and deploy them independently, then it becomes kind of like a microservices. Okay, so now coming to cloud. So I mean, in the last session also we were discussing about cloud, right? So I mean, most of you are aware of cloud at least, right? I mean, you guys have heard about cloud. Have any of you heard about, mostly I'm referring to the college students because most of you might have heard about who are working, cloud native? Have any of you heard about the term cloud native? No, maybe, okay. So that's very interesting also. So have you heard about the term native? When we say I am native Bengali, meaning I was born and brought up in Kolkata, I can speak the Bengali language. Similarly, somebody is like, for example, a native Rajasthani. Okay, similarly, so basically native means it's in my blood. So when you are doing something on cloud, okay, there are many ways you can do it. So for example, what is cloud? As somebody was saying, cloud is somebody else's computer, right? Somebody was saying it. So basically it's like I have a huge amount of compute, I have a huge amount of storage. So these are the most two important things that anybody needs to deploy an application. You need compute. So even your mobile phone, it has this 4V CPU and all of this thing like Snapdragon processor, Qualcomm processor, right? 6 GB RAM, and then you also need storage. That is where we store our photos. If you have your compute and you have your storage, then you basically have a system that you can work with. Now there are many ways to handle this in a cloud environment. So what is one way? You, for example, rent a virtual machine. Basically it's a server. What's a server? Server is a compute that you can work with. Now say for example, in your server, you are deploying an application. That is very simple. You get a server, you RDP into that server, you log into that server, and you deploy your application. But is it cloud native? No. That might not be cloud native because you are not taking the full power of the cloud. So what is the full power of the cloud? The power of the cloud is that I only pay for what I use. That is the most important power of the cloud. So say for example today, when you go to buy something, right? Say for example, you are going to buy a bread. You are going to buy bread, but you only need 3 breads. Basically, you just need 3 breads, but they are not selling you individual breads, right? So you get an entire bread box kind of. So maybe you are paying 15 rupees, whereas you only needed 3, so you should have paid maybe 3 rupees. So this is what cloud is giving you. You don't have to buy or rent a big server. You can basically just rent that server per minute, even per second. So say you start the server now, in 1 hour, you stop the server, you just pay for that hour. That is very important. That was not possible earlier. So this is cloud. Similarly, you have the power of independently scaling. So there is infinite, the concept of infinity. It's backed by infinite compute and infinite storage. So this is also the idea. Now, what is cloud native? Cloud native is application programming that takes full advantage of cloud computing. So your application needs to be deployed, needs to be created in a way that takes advantages. So our platform is providing you a lot of advantages, right? Say for example, in your house you have a microwave. That's very useful for you to cook or heat food. But if you don't take advantage of the microwave and you're still using, say for example, your oven, or you are using the same kind of attitude or same kind of practices, then it will not work. So this is what cloud native is about. So what is the problem today with enterprises? Again, I am trying to simplify this as much as possible because most of you guys are from college. So I will tell you what is the problem. Say for example, say you guys are starting a party. Say 5 of you are starting a party and you buy alcohol, as simple as that, okay? And you start a party, there are 5 people, you buy say 2 bottles and a few glasses. Make it 50 people. Still manageable, okay? I mean, you can kind of call your friends, get the alcohol, get some more glasses, make it 500. Now it's a little bit difficult. Where will I keep these people? Where will I get so much of alcohol? Who will pay for it? Make it 5,000. Make it 50,000, now make it 5 lakh. So a party of 5 lakh people, where will I get the alcohol, man? I don't know. Very frankly, I don't know, right? So anything at scale is a problem. This is the problem that all enterprises will hire you to solve. That is the single problem they are trying to fix. The same problem that you have been able to fix in your day-to-day life, if you multiply it with a threshold of say 1 lakh, 20 lakh, 50 lakh, 80 lakh, I don't know whether you guys remember when Flipkart was doing that big billion sale, right? Every time in the initial days, The moment they would announce that I will give you Redmi in 2000 rupees and stuff, people will log into the platform and the system will crash. It's a very standard thing that used to happen in the beginning days. Why? Because of the scale. Because of, like, say, when 200,000 people are trying to log into the platform, it's a whole together different thing than you doing it on your laptop. So what can help you in scale? Can you tell me? What is the only solution to fixing problems at scale? Sorry? No, auto-scaling is obviously a solution, but I'm saying from a generic concept. Say, for example, if we think about that party concept, okay. So you are very okay with organizing a party for 500 people, right? But when I ask you to organize a party of 500,000 people, it's a problem, right? And how do you fix that problem? Standardization. What do I mean by standardization? Put in a process. Ask everybody to bring their own liquor. Ask everybody to bring their own glass, right? Have a WhatsApp group. Everybody should log into that group, tell them yes, 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 or maybe create a form or something. So basically, any form of standardization can help in fixing problems at scale. And what is the biggest enemy of fixing problems at scale? Non-standardization or exceptions. There will be a friend who will call, you know, the alcohol shop is closed near my home, I cannot bring, please arrange. And that is how the problems will start, right? So anything that you cannot fix at scale is a problem. And this is what we as enterprises try to solve every day. How can we, for example, fix problems at scale? Okay, perfect. So many of these things I will kind of, so okay. So now from a standardization perspective, again, like I was trying to say, we have to standardize things. So what are some of the things we can standardize? We can standardize the architecture. What can I say? Say, for example, I have started a company. Okay, I have 20 people. Now 5 developers are using JavaScript, 5 are using C#, 5 are using Java, and 5 are using, say, Python. Everybody is coming to me, sir, this is not working in Python. This is not working in JavaScript. What can I do? There is too much movement, right? Too much chaos. So we need to standardize the programming language. There are enterprises, for example, there are enterprises I've worked with, which have told people, you have to use C#. There is no other way, because it's a standardization. Again, we don't want exceptions, we want standardizations. So this is a very important concept, that some of these concepts, if you can take with you today, that is even okay, because many of these technical aspects might not seem relevant to you today, but at least some of these concepts, if you can kind of think about it and answer some of them, it will be helpful. So architecture, programming practices, and patterns, these are some of these things that are very interesting, and you have to standardize them. Everybody in your company should do it the same way. As simple as that. All the hotel rooms today have, for example, one say bathroom, hypothetically saying, or 2 windows. You will not find one room with 3 windows, for example. All the rooms of the same category. Maybe a deluxe room might have 3 windows. So why did a hotel build? Because it's very easy to scale. Everybody knows in every room you have to. There is no surprise. So always try to standardize stuff. This is what enterprises are looking for. Okay, have any of you heard about CI/CD? Okay, okay. Maybe you can share something about CI/CD. Continuous delivery, exactly. So what is incremental delivery? So incremental delivery is actually realized with DevOps. So they are not conflicting, they are rather complementary. And I will discuss maybe separately with you, no worries. So they are actually complementary. Anyways, so what is CI/CD? It's the fact of building an application. So how do we build an application? Say, for example, we have a C# code. You go to Visual Studio or Java, maybe in Eclipse, you right-click build, right? What it does, it generates a jar file or some sort of a package. That package is stored somewhere, and that is called CI. And when you deploy that package to kind of a compute environment, that's called CD, as simple as that. But what is the problem today that enterprises are facing? Enterprises are facing a problem called pipeline sprawl. This is what we are trying to say. When you have 4,000 teams in your organization, each developing pipelines in a different way, it's a big problem. It might not be a problem for small startups, but for big enterprises, it's a problem. And what is the solution? Standardization. So the same solution So we have to find a way to standardize our pipelines. Every single pipeline should follow a set of standard practices and patterns. They should not be different. Obviously, there will be nuances. So my party will be a little different than your party. Maybe in my party, I am allowing, say, for example, water. In your party, you are allowing alcohol, hypothetically saying. But the idea is the same. So how do I standardize pipelines? And we have a central kind of a team. Again, I'm moving a lot of this task called DevOps Dojo. So anybody have any of you heard about DevOps? DevOps you have heard, right? But I don't think anybody of you have heard about DevOps Dojo. Right, okay, so DevOps Dojo is another part of DevOps where we are giving, so what is dojo? Dojo, if you search, it's like in Japanese, people are kind of doing kung fu and karate in a ground. Okay, it's like a dojo, they call themselves dojo and there is a master and people, so Bruce Lee movies, they go to a dojo and they fight amongst themselves and stuff like that, okay. So DevOps Dojo is a similar concept of very highly experienced DevOps people. Okay, because I am part of the DevOps Dojo team. So we are a very highly experienced DevOps people. We are kind of creating those basic pipelines, the basic standards that we are then asking all the other teams to follow. Again, what is the advantage? Everything is standardized. Okay, so this is a reference application or a reference. For example, I have my DevOps Dojo team, so I am part of the team. I have my security team. I have my DevOps engineers. All of us are brainstorming and creating a standard pipeline. So that standard pipeline I'm storing in a repository. Then what I'm saying, anybody needs, say for example, I have created this standard kind of an architecture, standard. Now say for example, you need something else. You are a business team, you want to deploy e-commerce application. Okay, you don't have to develop everything from scratch. You come to my team, you ask me, give me the standard. You will take the standard, you will download it, and you will modify some of the parameters and you will have a working pipeline, basically. Basically, that is the idea, yeah. Yeah, so DevOps governance model, if you see like a DevOps co-op operating model, DevOps model, DevOps Dojo is a part of the architecture governance board. But it's not just the only part. So it's not like that they are leading, they are a part just like many other parts. For example, you might have representation from other teams also. Okay. So anyways, let me very quickly come to something. How many of you have heard about open source? Perfect. How many of you have heard about InnerSource? Okay, so who has heard about open source? Again, anybody? Okay, man, can you just help me out? What is open source to you? Open, exactly. Exactly. So basically, it's like the code is in GitHub, as simple as that, right? So for example, I am able to go to GitHub, download the code, build the code, test the code, make some changes, and then again upload to GitHub. I can contribute, basically. Right? So say for example, this is an open source community, right? We call them an open source community. So there is people, say for example, you have created a code in India, in Delhi, and maybe there is an issue in your code and somebody in Brazil is fixing it. That happens in open source, right? Because everything is open. You have very good documentation, you have very good practices. Anybody in Brazil can go to your code, go to your repo, download it. Okay, this is a problem. Fix it, raise a pull request. You are a reviewer, you merge it. Very good. This is the basic fundamentals of open source. Complete collaboration, complete transparency. No working in silo. Everybody knows everything, right? So InnerSource is open source in an enterprise. So now think of open source within, say for example, a company like say Accenture, right? Everybody is doing their own thing. There are different teams within Accenture, but my team has no idea about your team. Say for example, I have created something, a web application, and I have created the front end, you have created the back end. My front end is calling your back end, okay? But your back end has an issue. What is my option? I have to talk to you. I cannot go into your code and fix it. I cannot today. If you see our siloed model, InnerSource breaks that. In InnerSource, the concept is very simple. So if I go here, say for example, you have the main branch where the actual code is residing. Okay, that is the main branch. But you, for example, you are curious enough and you are knowledgeable enough that you want to fix some issue. You just create a branch from the main branch, just like open source. You commit the code and you raise a pull request, it goes to the main. So basically open source concept, if you take within an enterprise, it's called InnerSource. I'm simplifying a bit, but that's it basically. So how can it help? How can InnerSource help? InnerSource can help in the same way that open source helps people. Say for example, I am a team of 5 people, just 5 people. I have created a web service, right? Say for example, there are many issues with the web service. I am only 5 people. We can only fix as many issues, right? But say for example, I have very good documentation. I have a very good InnerSource kind of a operating model. The entire company becomes my workforce, theoretically. Anybody in my company can go into my code, find that issue, and fix it. That is the concept of InnerSource. And again, that is what I'm trying to say. What was the problem that we were trying to fix? We are trying to scale things. We are trying to handle teams and handle issues of 400,000 developers. It's not one developer, two developer. It's like 4,000 teams, 400,000 developers. So the only way to fix it is with scale. So I, as a team of 5 members, cannot fix this, right? So I need the entire company behind me. So that is what we are now trying to do. We are trying to increase the adoption of the microservices by having pipelines, which are standard pipelines, and then we are asking different teams to contribute to those pipelines with an InnerSource approach. Again, there is I can understand there is some confusion because again, these are a little bit complicated topics, okay? More suitable for enterprise audiences, but I'm trying to make it as simple as possible for college students. So what is the key learning from all of this? Very quickly, right? So if, for example, we kind of summarize what I was trying to say, anything that you do at scale is an issue. Whether it's organizing a party of 500,000 people, or is it a company like EY with 350,000 developers. Okay, so anything at scale is an issue. And what is the way to solve problems at scale? Standardization. So wherever possible, we should try to standardize things as much as possible, whether it is standard code, whether it is following a standard architecture, whether it is following a standard programming language. So we should, for example, ask everybody to shift to Java. Just because we will have all the resources, everybody only in Java. That will help our productivity, in a sense. So all of this standardization you need. So for a microservice and a CI/CD, try to create CI/CD standard pipelines that can help you, and then have InnerSource methodologies and processes so that the entire company becomes part of your team. Is not just 5 people or 10 people who are working on a project. With a good InnerSource operating model, the entire company is basically part of your workforce. Okay, but anyways, I will try to kind of, yeah, sorry. Yeah. No. See, enterprise asset libraries were always there, kind of, right? Many companies had standard libraries. So for example, there were companies where, say you want to do a data load. Say there is a file, you want to load that file into some sort of a data store. There were standard ingestion methods. Everybody was using it. But there was only one team who used to maintain that. Now we are going a step further and we are saying you can also raise a pull request and change that. Exactly, basically everybody. So it's a distributed, federated kind of a model. Okay, perfect, I think. And let me just again, just for your curiosity's sake, again, many of these things will not maybe make a lot of sense to you because you have not again been to the IT industry. When you start, it will. But the idea is, only way to scale is, as I told you, to have standard things and then make them easily accessible. So for example, I need a web application. You will see 80% of the web applications are the same. It has a front end, it has a back end, it has a middleware. So why should I not be able, as a user in a company, why should I not be able to go to some sort of a marketplace, just like Amazon marketplace? I should go somewhere and select a web app. I will just click, I need a web app, and a web app will be created for me. So that is the future. That is what we are calling self-service via IT catalog. And we want to have a cross-functional architecture board. Again, this it might not be very relevant. And again, implement InnerSource patterns. This is also very important. So with this, I'm kind of trying to keep it short. And is there any question, for example, in any other topic, even, for example, not maybe related to this, maybe also any confusion with cloud, DevOps, any concept of DevOps, CI/CD, anything that is interesting to you guys? Otherwise, I can end the session here. I think, yeah, sorry. Yeah, so see, DevOps, so see, what is basically, what is a virtual machine, right? So a virtual machine is basically a physical machine which has been virtualized for you, and then you are logging into that machine, you get say 4 vCPU and 128 GB RAM, basically, okay? And you have some data and you do it. Docker is basically, you have a container runtime on top of the virtual machine so that you can run multiple container processes. Basically, you take a container. So basically, it's more lightweight than VMs. So how much time does a VM take to boot up? Like I think 2 to 3 minutes. Whereas a container might boot up in a few seconds. Okay, this is one, it's stateless. So there are many. So how does it relate to DevOps? These are not contradictory stuff. These are all complementary stuff as part of the overall cloud native model. So what is an overall cloud native model? You have basically microservices. So so say for example, you have a code. So where do we start with? We start with a code. We have written a code. We need to build that code into a Docker image. You might have heard about a Docker image. So how do I go from code to image? That is CI, continuous integration. Simple as that. I have in my left hand source code. I apply a CI pipeline on top of my source code. I get a container image. As simple as that. That is where my CI ends. I keep that container image in a very safe, secure container registry. I have to keep the image somewhere, right? I keep it in an Azure Container Registry, hypothetically saying. So that is where my CI ends. But what is the image good? It has no value in itself. I have to deploy it to a compute to be able to derive some value out of it. So I take that image, I run a deployment pipeline called CD pipeline on top of it, and I deploy it onto a Kubernetes cluster or to a Docker Swarm cluster, any sort of a cluster. Why do we need cluster? Because individual machines or nodes can go down. Every time, always remember, whenever we deploy something, we should have 2 instances of it. If one instance goes down, there will be another. So that is why we call it a cluster, minimum 3 kind of a node to maintain the quorum. So this is a concept. They are not contradictory. Docker and Kubernetes are compute orchestration methodologies to deploy. CI/CD pipelines are automation or automated ways for you to help from source to destination, nothing else. Okay, perfect. I think I'm out of time also. Perfect. Thank you so much. And guys, I mean, if you want to connect with me or something like that, you can either connect with me later or you can connect with me on LinkedIn also, whatever you prefer. But I have reached my maximum connection, so you will have to kind of follow me. Okay. Perfect. Thank you. Take care. Oh, sorry.